So in module 4 here, we are shifting our emphasis a little bit from what we did in the last module. So overview of what we did and where we're headed. In module 3, we focused on linear stuff. For the most part, we looked at a few other things. Like you might remember in the beginning, we compared lines to those parabolas, to those hockey stick kind of shapes. But mostly we learned about the many aspects of y equals mx plus b. And the biggest thing here was the idea of slope and how slope is used in different applications throughout our existence. In module 4, what we're moving on to as of yesterday, we're switching over to mostly exponential stuff, which we looked at a little bit in the beginning of this course. And for those of you who took the previous course, you saw a tiny little bit of it there. So exponential stuff is where instead of having like a multiple times a variable, that variable is to some power. Or sorry, the power is the variable. So we have some base b and the power is x, right? So that one right there is the base. This right here is the power or exponent. Right, so for example, like 2 to the power x. If I made a table for that, x versus 2 to the x, if x is 0, we would have 2 to the 0, and hopefully you remember that is 1. If we have a 1, that's 2 to the 1, which is just 2. 2 to the second is 2 times 2. Oops, premature in that second there. If x is 2, we get 2 to the second. 2 times 2 is 4. If x is 3, we have 2 to the third power. So times another 2 would give us 8. And then after that, we kind of whip out the calculator because maybe we're not so familiar with our powers of 2. So like if somebody asked me, hey, what's 2 to the 11th power? Oh, I don't remember. I'll have to whip out my calculator. It's pretty big. So quick note on calculators. I like the Desmos calculator, and hopefully you have something similar, if not the same one. And it has some power buttons here for a square and then for any other power. So if I start with a 2 and I hit that square button, it's going to square whatever I put there. If I want a different power, then I hit the power button there, and I can type in any power I want, like 3 or 11. On most computers, there's a shortcut on the keyboard for powers instead of clicking the button. And on your keyboard, it is the, where's that? Shift 6, it's the little caret, that's what it's called. So if I do 2, and then I do Shift 6 on my keyboard, it raises me up to a power, a superscript, and then I can type the power in. And we'll use that on a spreadsheet in a little bit. So quick note on that. To do powers on a computer, something like 2 to the 11th power could be typed as 2, that caret key, that hat there, and then a whatever power, oops, like 11. And on most keyboards, it's above the 6 key, so it would be a Shift 6 to get that. So caret, Shift, and 6 on the keyboard. And often I do that when I'm typing into a calculator on a computer, and always I do it when I'm in a spreadsheet because it's the main way to get a power. So with respect to exponential stuff, my belief, my hope is that you're familiar with a few basic ideas that are going to help us work with that. So how powers work. So powers are related to repeated multiplication, right? And they have a base and a power, or the exponent, like we talked about before. And then there's some basic things, like if we take any number, almost any number to the power of 0, we're going to get a 1. If we take any number to the power 1, we're going to get that same number back. Right? Otherwise, if we take some base to a power like 4, that means we write the base 4 times and we multiply together. And just keep in mind, like let's go to, for example, 2 to the 4th. I would write down 2 times 2 times 2 times 2. Some people say it's the power is the number of times you multiply, but that ain't true. Check it out, right? 2 times 2 is 4. Then I got to multiply by the other 2. So I did 1 multiplication. 4 times 2 is 8. Still have 1 more 2 to go. 8 times 2 is 16. I multiplied 1, 2, 3 times. So the power isn't the amount of times you multiply, it's how many times you write the base. But many of us mistakenly say it's the number of times we multiply, even though we know that's not true because we know how to do it right? So my guess is many of us say something like it's the number of times you multiply, but what we really mean is the number of times you write the base. Other important ideas, there are some special rules for simplifying powers. I think the 2 most important ones are if you have the same base, and you're multiplying and you have different powers. So this one right here tells me to write out 3 2s. This one right here says write out 4 2s. So altogether, I've written out 7 2s and I multiply. If we multiply with the same base, we add the powers. So my hope is you remember that rule from your past life in math. A rule that's often confused with is the power to a power rule. So if I had something like 2 to the 3rd power, and then I squared it, well, squaring something means multiply it by itself. So that's 2 cubed times 2 cubed. Now I get the rule above that says, hey, add the powers. Okay, so notice that if it's a power to a power, you multiply the powers. Slightly different rule, but related. So power to power, we multiply the powers and keep the base. And those 2 are often confused. We got to keep those straight. Multiply, same base, add the powers. Single base, power to a power, we multiply the powers. Now, those are just shortcuts. The bottom line is what it means to be an exponent is the number of times we write the base. So if you're ever unsure about the rule, just think about writing the base out that many times, and that'll always clear things up. Example with another rule. If you have the same base, but you divide with different powers, you end up having a subtraction that happens. So that should be 2 to the 7 minus 3, or 2 to the 4th power. The question is, why does that happen? Well, 2 to the 7th means you have 1, 2, 3, 4, 5, 6, 7 2s all multiplied out. And 2 to the 3rd means you have 1, 2, 3 2s multiplied out. And anytime you divide a number by itself, you get a 1. So that's multiplying by 1. That's multiplying by 1. That's multiplying by 1. That leaves 4 2s left. Okay. So it's cool if you know these shortcut rules, but if you ever forget, you just have to think, what does it mean to be a power? It's how many times I write the base. And then from there, you can always solve the problem a different way. So this is another one of those shortcut rules, like the previous 2 I showed. Here, if we divide powers with the same base, we subtract the exponents. And my hope is, you did the prep yesterday and you read all of this and you tried all of this and it all went well for you. If you had any trouble with the prep, You can apply a late pass, do it again. Feel free to ask me questions. So some basic rules I hope you remembered about exponents. Other things that I hope you remember is working with percentages. And remember, percent literally means divide by 100. Divide by 100, which you could also write divide by 100. And think about the percent symbol, right? In the percent symbol, here's your divide, and here's the 2 zeros for the 100. So anytime somebody gives me something like 3%, that really means 3 out of 100. If I write that as a decimal, remember that's the tens place, this is the hundreds place. Slang is to say 0.03. Right, 0.03 is slang. The proper way to read it is identify the last place and read it that way. This is 3/100. That's the proper way to read it. And we've been using percents just a little bit. We did a few of them at the end of chapter 3 in that lesson 3.7. If converting a percent to a decimal is dividing by 100, then going the other way is multiplying by 100%. So here we have percents, oops, wrong color. We have percents to decimals. That's pretty straightforward. We just interpret the percent symbol, which means divide by 100, because that's what the percent symbol means. To go the other way, decimals to percents, we just multiply the 100% back in. And before I do an example of that, I just want to look at the number 100% for a minute. Consider that number 100%. What does percent mean? Well, percent means divide by 100. What's 100 divided by 100? It is 1. So this is a super important thing that's going to come in useful as we work in the next few sections, that 100% and the number 1 are the same number. 1 is 100%. Doing a conversion, like if somebody gives me the number 0.05, if I want to convert that to a percent, I just take my number 0.05, multiply it by 100%. I leave the percent symbol alone and I just do that multiplication right there. So 5/100 times 100 is 5, percent symbol hangs out. So 5/100 is 5%. So two different sides of the same coin. Next, review from lesson 3.7. In lesson 3.7, we came across the formula A equals P plus PRT. And we learned that we could factor this formula to pull the P out. So we get the P pulled out. I'm going to pull it out on this side for a change. And then if I pull that out, that's like dividing. P divided by P is 1 plus just the RT. And this is a super, super, super important formula right here. And I want to focus on that 1 plus RT for a minute. So this is our interest rate, right? So this is the amount of increase right here as a percentage. I guess it's the percent of increase. What's the 1? That 1 is 100%. 100% is the original value. And so that's another super important observation that's going to help us out in this next section, this idea that we can factor and simplify that. And it doesn't matter what we call these variables. So we're going to see things that look like X plus RX. And this could be something like X, maybe my family lives in Rhode Island. I went to visit them in Rhode Island this summer and I buy something for X dollars. And in Rhode Island, they have a sales tax. It's about 7%, I believe. So they're going to charge me 7% extra on anything I buy. So I go and buy something for $100. They say, cool, you're going to have to give us more than $100 because we have sales tax. So they're going to take that 7% as a decimal. They're going to multiply it by that $100. And that means I'm going to owe them, if you multiply that out, another $7. Oops, not percent, $7. Plus the original $100 means I'm going to have to pay $107 for this thing, right? The 100 is my original, and the 7 is my increase. And if I think about this in the factored form we looked at earlier, I can factor out the x. That's going to leave a 1 plus r behind. The 1 is my 100%, what I started with. The r is the increase. So in this case, I would have x times 1 plus 0.07. 1 plus 0.7 is 1.07. And often when we multiply by our variable, we write the number first. So 1.07x would be a shortcut for doing that. So then anytime I want to buy something, if I just multiply by 1.07, that's going to tell me what I actually pay. One last thing, and then we're going to move on to our next lesson. Sometimes the rate could be a decrease. So instead of being a positive, increasing something, it could decrease, like a sale. Like maybe there's a 25% off sale. Right? Whatever you buy started at 100%, whatever it cost, and then we're taking away 25% of that. That leaves 75% that we pay. So this is like my previous example. X is something I buy, but because of the sale, I get to take away whatever R times X is. Factoring that, I pull out the X, I get a 1 minus R. And this right here is my 1 minus R. So if it's 25% off minus, I pay 75%. So sometimes instead of increasing, adding on a rate, we're going to take away a rate. Depends on the context. All right, we're ready to move on to our next lesson.